Hi, my name is Derek Bingham. I'm a Senior Developer Advocate at AWS, and I'm going to talk to you today about improving your developer experience on AWS. Over the next 30 minutes, I'll take you through a typical developer journey, a journey that a developer would go through when building a new feature or a new piece of functionality and adding it to the app. I'll talk about how I would think about that, and hopefully we'll learn a few things along the way. So let's start off with what is developer experience. So my view, developer experience is about maximizing the effectiveness of software development by simplifying the process of developing, deploying, and automating. So it is an experience that happens throughout the software development lifecycle. And what is the software development lifecycle? So I like to split that up into two parts. The first part, and what I call the developer journey, is all around that local experience that you have when you're developing and debugging your code. So you've pulled a new feature off the backlog, or you're fixing a bug that you have to look at, and you sit down and you've got your IDE open and you start coding, you write a unit test, you locally debug, and you do all that great stuff trying to create that new feature or fix that bug. And then finally, after that, the next phase is all about how we as developers integrate and automate that feature or bug that we've just fixed locally. And that's the second phase of the developer journey. And that's the journey we're going to go through today in this talk. So let's start with develop and debug. So with AWS, developing and debugging your code, most developers I see will start off with one of these two tools, or maybe both. The first one is the AWS CLI. So that is the way, as developers, that we connect to our AWS accounts in the back end. We download the CLI from the AWS website, we initialize it and configure it so it will connect to our AWS account. And we use it to interact with the services that we're going to use and we're going to develop our software with. And as well as the AWS CLI, we can go into the AWS console and use the native web-driven IDE called Cloud9. So it's really easy to access. You can just click into the console, instantiate a new version of Cloud9, a new instance of Cloud9, and start developing. So it's a really great entry point into developing on AWS. But we're not constrained by those either. We can bring our own IDE as developers, the IDE that we are most comfortable with using into building software on AWS. So we have an open source AWS toolkit that is a plugin for all the major IDEs. So VS Code, IntelliJ, Eclipse, as well as main Visual Studio. And that allows us to interact quickly and cleanly with the AWS services from our local IDE. And again, that improves our developer experience. And then for the mobile developer, we can also use the AWS Amplify native mobile libraries. So if we're building a Swift or a Android app, then we can just pull these libraries in and they will allow us to interact again with the AWS services, so we can bring that functionality into our application really, really easily. So they're the set of tools that developers will use when they're building software that interact with the AWS services. Now, as well as those tools, there's two scaffolding, I like to call, applications that and tool sets and frameworks that we would like to highlight as well. The first one is Amplify. So AWS Amplify is our full stack web and mobile framework that allows developers to quickly build and scaffold applications. So when I say scaffold, I'm talking about you need a new feature that you want to add to your application, or you're starting an application from scratch and you quickly want to build the boilerplate code, the undifferentiated heavy lifting. You just want to get rid of that and want to get down to the nitty-gritty of building your applications and adding the features. So Amplify and SAM do that really, really well. Amplify will actually generate CloudFormation code for you. So it'll hide that complexity. When I say CloudFormation, I'm talking about the declarative way of defining AWS services. So CloudFormation, you can define AWS services in either YAML or in JSON, and it will build the services for you. So Amplify will abstract all of that detail away from you so you can concentrate on the features that you want to build into your app. And the same with SAM, our Service Application Model Framework. That is an extension of CloudFormation, and it allows you to quickly scaffold and build serverless applications. Both are really great ways to quickly get your application started or get that new feature into your application, scaffolded and ready to go. So there are some of the tools and frameworks that we can really use to improve our developer experience on AWS. But what else can we do? Well, we can develop and debug locally. Using the SAM and Amplify frameworks, it allows us to spin up API gateways, RESTful API service, or AWS AppSync, which is our managed GraphQL service. We can spin those two things up locally. So if we're building features that rely on them, we can test and debug those features against a local instance of those AWS services. So it's a really great feedback cycle, really quick, and allows us to get our application built quicker. As well as AppSync and API Gateway running locally, we can also run services like Dynamo, Lambda, and step functions locally. Again, that gives us a great way of getting a really quick feedback cycle when we're building out applications that rely on features that use those services. So the SAM framework allows us to do that. And then when we're happy developing, debugging locally, running against our local instance, it gives us great confidence when we go to deploy it into our AWS account. And we've got a number of different tools that we can use to deploy from our local environment into our AWS account environment. And when we can be confident that what we've built and tested locally will have very similar behavior to the feature when we deploy it to the AWS account. So let's have a look at one of those tools. I'm going to take you on a demo through the AWS toolkit for VS Code, and we'll see how to locally build, deploy, and debug applications using VS Code in the AWS toolkit. Okay, so let's have a look at this demo. So here I have Visual Studio Code. It's installed, and I've got the AWS toolkit installed. And the first thing we need to do is just check my connectivity to my AWS account. So here's the toolkit. I can see I'm already connected to Singapore region and the Sydney region. So let's use the toolkit, which wraps SAM CLI to build a serverless application. So I'm opening up the command palette here. I'm selecting the create new SAM application. I'm choosing my language, which is Node. And I'm just going to create a simple hello world application. Going to give it a name, and then the toolkit will generate the boilerplate or the scaffold, the application for me. So let's have a look at what it's created. It's created a little hello world in an app.js with some code. It's in Node, which will just simply give me a 200. And it defines this template.yaml, which is the extension point of CloudFormation, which I was talking about earlier. So it will create a handler for the Lambda function and also an API entry point. So as this boilerplate code is boring, I'm going to add my own, which is a little bit more interesting, but not very. But I'm going to do this so I can add a breakpoint. And what I'm going to do is execute this code and create a run configuration. So here's my run configuration that I've created. And now if I go to the run command, I can run this application. So if I hit run, it should then start my debug session. And there's my debug session starting up. Using the SAM toolkit, and there we go. I've stopped at my breakpoint. I can introspect all the variables that I have available to me. I can make sure that what I expect is what is there, and I can step through the usual debugging things that I can do through my IDE. I can check my return codes. I can see that everything is functioning correctly. And that is a really good experience because it helps me quickly build that application. As well as that, I can start thinking about how I'm going to deploy this. So SAM deploy guided will set up a deployment configuration that I can reuse if I run it from the right directory, that is. So if I run it in the right directory, you can see that SAM deploy guided starts to prompt me for how I want this application to be deployed from my IDE. So I quickly set that up. I give it a name, I give it the region that I want it to go to, and I confirm everything, and it will start building me a deployment configuration. It will say, check about authorization, access control, and do I want to save the config, which I do. So then it will deploy this application into AWS. Once that's finished, we can then go and actually see the Lambda function using the AWS toolkit. There's another feature of the toolkit where you can browse the Lambda function that you have. So let's see the output of my Lambda function. It's now running on AWS, and there we go. Hello and welcome to our serverless application. It's now running on API Gateway, invoking that Lambda function on AWS. You don't believe me? I can browse to it using the toolkit. And there's my Lambda function, AWS toolkit, hello world. And I can actually invoke it from the IDE directly. So here I am invoking this function locally. So it will invoke it on AWS for me and check that my deployment is okay and that everything is functioning as I would expect. So that, again, that's improving and really a great developer experience. It helps me build my applications quicker. So what else can I do? I can change my application. So I'm just doing a quick change of this application code, and I'm going to reuse that deployment config that I just generated using SAM. So I can pretty much go save, one click in the command palette, I can go a SAM deploy, and this will redeploy the same Lambda function from my IDE into AWS Cloud really, really quickly. So again, I'm mutating, changing the application. I can see those changes reflected really, really quickly on the AWS service. So as it deploys, it should be deployed. There we go. So it's deployed now. And let's just check using the URL that we've got. We'll check to see that it's deployed correctly, and there we go. There is our new service, and it's been changed. So as you can see, I've just shown you how you can quickly scaffold your application using the toolkit and how it can be changed really quickly, and it's a really great way of improving your developer experience. Okay, so that is develop and debug. We've looked at the tools you can use, the frameworks you can use to scaffold apps, and we've also looked at an example of one of those, the AWS toolkit for VS Code. Next in the developer journey is integrate and automate. This is where we bring our code together with other developers and we share it via source control repository, but also we need a way of building and deploying it into higher level environments like tests and production. Here is what I see as the common steps that a developer has to think about when automating and integrating their code. So you have to think about what source code repository to commit your code to. We have AWS Code Commit. Then on to how to build it and provision your environment. So we use code build and CloudFormation as the provisioning tool. And then on to code to deploy that the artifacts. So the artifacts being your code, as well as what infrastructure you want to provision. And that's all orchestrated by AWS Code Pipeline. Let's drill down a bit into infrastructure as code. What is infrastructure as code? So infrastructure, you need infrastructure as a developer to run your applications on. So over time, we've evolved how infrastructure as code, what it looks like. Originally, we were all just RDPing or SSHing into boxes and writing scripts to enable us to provision services. But that's evolved over time. And now, via CloudFormation and things like Troposphere, and then finally into Pulumi and the AWS CDK, we have abstracted away that complexity of building infrastructure on AWS. So what is the AWS CDK or Cloud Development Kit? Well, this is where we can build our infrastructure as true code. So code that we as developers are happy writing, we know how to write unit tests for, and we have got our favorite IDE to write it in with all our different linting plugins and plugins that help us be more efficient and improve our developer experience. The CDK supports a lot of those languages. It's made up of a core framework where we define an application. It's full of stacks, and inside the stack is resources or our services that we're going to use. We have a construct library, which is a really reusable components that we can pull into our application as we build it. And we also have the AWS CDK CLI is what we use to start interacting with the CDK and provision those resources on AWS. So before we had the CDK, we had to use CloudFormation. So we would have a parameterized template. We'd inject that into a CloudFormation script, either built in YAML or as JSON, and that would then provision our resources. CloudFormation can be long and verbose, and speaking frankly, as a developer, I didn't consider it a true development language. However, the CDK is a lot different, where we build an application like any application using code. It then generates the CloudFormation parameterized template for us and injects that, and it starts then building our services. So that abstraction layer of actually using code really, really helps. So let's see that in action. Let's go and look at a demo building a really simple application using the CDK. Okay, so here I have my terminal. I'm just going to create a folder where everything will live. So once that folder is created, I can then check what version of the CDK that I've got installed. So I do that by going CDK version. This will tell me that I've got the latest, which is 1.63. Always good to have the latest CDK version installed. I then initialize this project. So I go CDK init and then choose a language. So this time I'm going to use TypeScript. I hit enter and it will then initialize the project. So it'll create a Git setup. It will create all the folders and files that I need. And then I can start bootstrapping my application. So CDK Bootstrap connects it to my AWS account, which it introspects from the AWS CLI I've got installed. So then I open up my favorite IDE, VS Code, and inside you'll see all of the files that CDK init has created. So we've got a lib folder, which is my stack, which I use to provision all my resources. And then also I need to install my dependencies. So all of my dependencies I'm going to use for this application is the API gateway and Lambda. So I'm going to create a very simple API. I'm just going to create a Lambda function that's going to run when my API is hit. So here I am creating my Lambda function. It's very simple. It's going to be called hello.js. And inside it's just going to return 200 and some text, which may be familiar from the last demo. And then I'm going to start defining my infrastructure as code using the CDK. So I start with Lambda. I define the Lambda function as welcome Lambda. I define it as a function. I give it a name called hello handler. And then I give it a runtime. So the properties inside are a runtime of Node.js, and I tell the CDK where the code is. So that's from asset. So I can, as well as an asset, I can pull it from a bucket or inline or from a parameter. And then I give it the name of the handler itself, which is hello handler that we just created. Next, we need an API to invoke this Lambda function. So I'm creating a hello API, which will provision an API gateway instance. I give it the argument of welcome Lambda, and I just format all that code so it looks really nice. And that is it. I have just defined an API gateway with a Lambda handler, which will invoke when the API is hit. So let's do a CDK synth. So what CDK synth does, it creates the CloudFormation template. So as you can see, the CloudFormation template that you'd have to build for this would be around 550 lines, whereas the CDK code is 19 lines. That's a lot better and a lot better developer experience. Next, I'll do a CDK deploy. So what this will do, this will deploy that code via an S3 bucket into my AWS account that I'm connected to. And there it is, it's all deployed. And now let's see if it works. So I follow this link, which should bring me to a GET request on my API gateway. And if I just make that a little bit bigger with the /hello, which was my endpoint, /hello, then you'll see, hello, and welcome to our serverless application. So that was really easy to do. I basically built a Lambda function API gateway and provisioned it in the cloud in a couple of minutes. Also, you can do CDKs, a CDK diff. I'll show you that now. I won't do a destroy yet. I'll do a CDK diff. So what CDK diff does, it will show you the differences between the deployed version of your code and what you've got locally. So I've just removed the API gateway layer, and now I'm doing a CDK diff. So here is the output from CDK diff. It's telling me that, I've removed some stuff that hasn't been deployed to the back end. So it's a great early warning if you're working in teams, so you don't get drift in your provisioned infrastructure. And now I'm going to do a CDK destroy. And this will remove everything from the provision services. So that will allow me to then remove all of the stuff that I have just provisioned. So that's a quick overview of the CDK. Okay, so what have we learned so far? We've seen how we can use the CDK to easily integrate not only our provisioning of our backend services, but also our code, and how we can, as developers, get a really great experience building out our infrastructure in the code that we love, which is great. But what about the next step in the development journey? What about automating that entire pipeline from getting the code, building it, and then deploying it into our environments? Let's see what that would look like. So I'm going to introduce you into a new construct for the CDK, which is CDK Pipelines. What CDK Pipelines does is exactly that. It builds a pipeline that allows you to check out source code, pull it down, build the artifacts, and then deploy it to different environments. It applies best practices along the way, so you don't have to think about that. And it also applies the right design decisions. So again, you don't have to think about that. And then finally, it applies building blocks. So the building blocks that you need to build a pipeline. Could be a complex pipeline, could be an easy pipeline. All the building blocks are there within the CDK Pipelines construct. But when I talk about constructs, what do I mean? So the construct is a reusable piece of code that that CDK provides. Now, there's a number of levels of construct. The first one is the CloudFormation resources that the CDK generates itself. So that's an L1 construct. And then if we go up the abstraction layer a little bit more, we get to L2, which is the CDK core libraries. So like Lambda, API Gateway that I showed you in the last demo, that's L2 constructs. And then finally, the last level is the purpose-built L3 constructs. And that is an even higher level of abstraction, and that is where CDK Pipelines fits in. So what does CDK Pipelines build for you? So this is a slide showing you exactly that. So it starts off with a source step. It checks out or pulls down your source from a source repository, it could be GitHub, and it builds that source in the next step. Then the third step is update pipeline. This is the cool bit about CDK pipelines where they actually update themselves. So if you, for example, check in a new piece of code that defines a new build stage or a new deploy stage, CDK pipelines will actually add that to its pipeline without you having to do anything else. So that's what update pipelines stage does. The next one is publish assets. So that's where your assets are for your artifact that you want to publish. And then the next couple of steps are the stages. So a stage is where you would deploy your assets. So would it be a dev environment? Would it be a test environment? Or would it be a prod environment? You can define these as stages. And then also, as part of the stage, you can define what sort of approval process you need to go through to get through each phase. So could it be manual approval? Could be integration tests? Could be more complex tests. It's up to you when you define the stage. So let's see what a CDK pipeline looks like in the next demo. I'm going to build one from scratch. And I'm going to use the source code I used in the last demo. And we'll see how we can automate that code and publish it to a test and a production environment. And maybe even put a manual approval step in there along the way. Okay, so the first part of this demo is defining the code, the source repository of where I'm going to store my code. So here in Secrets Manager, I've just defined a GitHub token because a GitHub token because I've just created a fresh source repository in GitHub where I'm going to store the code for this CDK pipeline I'm going to build. Next, I go into my IDE, and we'll go into the project that we just finished. So that initial CDK Hello World example I did in the last example, and there it is. Hasn't changed at all. So the first thing I got to do is bring in the new dependencies that the pipeline uses. So I'm installing a number of dependencies here, pipelines, code pipelines. All of those are required, and these are core constructs that AWS provides. And so I'm just installing them all again, and it'll quickly be pulled down. And while there's been installed, I will then build out the pipeline. I will build out a stage, and I will then invoke that pipeline and that stage from a commit from source control, which is really, really cool because I can control everything, my pipeline and my application, from source control. And now I'm pulling in the pipeline, so the higher level abstraction construct is called pipelines. So the first thing I want to do is to start defining my stage. So what's a stage? So a stage is a wrapper around the piece of work I want to deploy. So in this example, the piece of work is a web server. So a web service, my API and my Lambda is my web service that I'm going to wrap in a code pipeline stage. So I start writing that stage and I start importing the stack that I'm going to wrap. And this is the stack we created earlier. So this is the starter stack. I'm going to pull in from my CDK starter file, and I'm going to wrap that in a CDK pipeline stage. So here I'm just creating the constructor. If you see it, it extends stage as opposed to stack. So this is the difference. Otherwise, it's very similar to the last constructor that we created when we created the stack. So the first thing I'm going to do is define what service. I'm going to create a new service. This is the wrapping service, which is a CDK starter stack. I'm going to pass in this, which is the scope, and we do use that to connect everything together in CDK land, and I'm going to give it a name. It's called web service. Once I've defined the service I'm going to wrap, the next thing I need to do is get the some sort of URL. So this is an output from the stack that I'm wrapping. I need to expose that output to the stage. So for example, if I'm deploying this stack wrapped in the stage, I need to know where the stack is deployed to. So where is the URL that I need to hit? So I'm defining that now. I'm defining it as a simple parameter inside my stack that I've written, and I'm exposing that as public so the stage can then pass it through to the pipeline when it gets called, so that we know where the endpoint of this web service is. So all I do is define that as a CFN output, so the CloudFormation output, and again I pass in this and give it a name. So I'm just going to call it simple a URL. So that is the properties of that. So very simple, which will be the actual URL of the API. So once I define that, it'll be the API integration with, i.e. the Lambda integration URL. So that is that. So my URL is defined. I'm now exposing it, and now I can use it within my stack. So next, I'm going to start defining the pipeline. So the pipeline itself is the stages that we define. So it's where to check out source control, how to build our artifacts, and then what stages we want to call. Do we want to call a test stage? Do we want to call a prod stage? So this is what goes inside the pipeline. So I'm quickly, again, just defining the constructor. Again, notice that it extends stack, so pipelines is a stack. And then just calling super on that. And the first thing I need to do is define where I'm going to get the artifacts from. So for the code pipeline, there's two types of artifacts. There's a source artifact, and there's also the cloud assembly. So if source artifact is like the incoming artifact, and cloud assembly is the outgoing. I then define the pipeline itself. I'm going to call it my service pipeline. I'm going to define the cloud assembly artifact and the source action. Source action I'm going to define is reaching into my GitHub repository, and this is where I need my token, which I showed you earlier. I grab that token from Secrets Manager, and then give the arguments of owner and the actual repo name, which I can't remember. There, that's it. Yep. So I grab the repo name and push that in too. So now I've defined my source action, so the pipeline knows where to grab the source for this pipeline. Once I've done that, the next piece I need to define is a build action. So so this is a web service, so the build action is npm run build, because that's all I need to build this node app. So I define it, I define the source action, and I define my build action, or synth action, what it's called, which passes the source, the assembly, and the build command. Now I need to actually call this pipeline. So I go into my bin folder and I remove the old stack that I was previously calling, which is just the web service itself, and I call the cloud pipeline stack, or the CDK pipeline stack itself. So once I've called that from my entry point, that means that when I go CDK deploy from this application, it will actually run the pipeline stack. So the next thing I need to do for this calling code, I need to pass some props in. So the props I'm going to pass in are the environment props. So the account ID I want to deploy this stack to, as well as the region. So I'm doing this as it gives me the flexibility of where and I want to deploy this pipeline. In terms of what account I want to deploy it to, and then what region I want to deploy it into. So that's all the pipeline done. The next thing I need to do is start checking it into Git. So I'm just adding my remote, which is my new repository. I'm going to commit everything that I have just created. Do an add A, and then a quick commit message, and push that up into Git. And that will mean that my code is ready to be read by the pipeline. Once I've pushed the code into Git, the last thing I need to do to create this empty pipeline, because I haven't actually defined any stages in the pipeline yet, is to do a CDK deploy. And what the CDK deploy will do, it will provision my first initial copy of the pipeline into my account. And so CDK deploy, and that will push all of my code up. See, it's quite a considerable amount of code, and I've written it in less than 5 minutes. And once that pipeline stack is created, we can have a look at it. So here we are in Code Pipeline. Here is my pipeline stack. You can see it's already started building the source. It's updating itself, so it's creating this pipeline. And here you can look at the logs and see this pipeline being created. Still in progress. So while that goes through, we can start thinking about how we're going to add stages to this pipeline. So if you remember, I created the abstraction for stage, but I actually haven't called it yet. So let's start calling that stage abstraction. So the first stage I'm going to add is the test or UAT stage. And so I'm going to go pipeline, add application stage, a new instance of my code pipeline demo stage, and call it test. I'll then add some props to this stage. I'll give it an environment, so I'm going to give the account number and the region. So this again gives you even more flexibility. So I can say, okay, for stage test, for example, I can put you into account X, whereas stage production, I can put you into account Y. So that will separate and give a nice blast radius, all in 3 lines of code. So I'm now just defining those 2 stages. I've got test and I've got production. So once the stages are defined, the next thing I need to do is, how does one get from one stage to the next? So this is where I can add an approval. So I'm adding a simple manual approval here, but I can also add more detailed approval steps, like unit tests. So I can add actions using this interface that allow me to define unit tests. So I can say, after my stage has been deployed to test, run these bunch of actions, which could be smoke tests, it could be tests, unit tests, integration tests, and then if they pass, deploy it into prod. So you can do all that inside that couple of lines of code. Very, very powerful and a great developer experience. So once I've checked that all of that code works, the next thing I do is commit it and then push it up into GitHub. I don't have to do a CDK deploy. I don't have anything else because my pipeline is now directly driven by my source control. So you can see source control's already picked it up. It started to build the pipeline. It's updated itself. So it's added the new stages, which is so cool. So test and prod. I'm do my manual approval step. I hit approve, and then the pipeline will next push my artifacts into production. And that is fantastic. So that is a great developer experience in that in a number of lines of code, I have built my entire build, deploy into UAT and production for my application. Really, really easy. And now I'm just checking the URL. So this is the URL I've exposed. And there we go. And I think you've CDK'd your first pipeline. So that is CDK Pipelines. See how easy it was to just create that build and deploy pipeline in a number of minutes. It's usually, as a developer, it could take days. So that was integrate and automate. We've seen how easy it is to build out a full build and deployment pipeline. And we've seen what tools you can use to do that. So the developer journey is complete. We have built our code, we have debugged it locally, we've tested it locally, we've deployed it, and we now have full automation to deploy it through test into production. Job done. So thanks for listening. Please, if you want to learn more about AWS, look at the Application Resource Hub. You can get more information here. We also have great tools and learning from training and certification and a lot of different tracks on how to get up and skilled in AWS. And then thank you. Thanks very much for listening. Please provide some feedback. Here are some more links. My name's Derek. I'm a developer advocate at AWS. Thanks very much.